In these problems, we are summing terms in a sequence. So if you look at this top one here, it says 4 plus 8 plus 12 plus dot, 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 all the way up to 432. So this is a sequence of numbers from 4 to 432, and we're supposed to add them all together and figure out how much that equals. With a long sequence like this, it would take you a long time to do it with a calculator. So we don't want to do it that way. We want to find out a better way to do it. There's also some notation for making sequences a little more compact on the page. So this big Greek letter sigma, it stands for a sequence or a summation of a sequence. In this case, starting with 1, with j equaling 1, and then ending at 122, but that's for this expression of j. So actually the first term of this one, you'd have to compute it by putting in 1 for j. The last term, you'd have to compute it by putting in 122 for j. So let's see how we go about this. On the first one, what we want to do actually is use the formula for the sum of the items in a sequence. And it's this, the sum is equal to n, which is the number of terms you have in your sequence, times the first term plus the last term, all of that divided by 2. Now some of that we know. I can start actually filling this out. So our sum here is going to equal, well, I don't know n yet, but I do know the first term, that's 4, and I do know the second term, or the last term, that's 432, and that's all divided by 2. So what we need to do is figure out the number of terms here. Maybe you know how to do this already, but sometimes it can be confusing depending on where the sequence starts. So we've got another formula here for finding n. You need this other number d. D is the difference between each step. So we go from 4 to 8 and then from 8 to 12. So it looks like d is 4. So let's start filling in this formula. D is 4. And then we have n minus 1. Well, we don't know n, so we'll leave that. We do know a1. That is our first term in our sequence, so that's 4. And that equals a sub n. That's our last term, so that's 432. So now we should be able to do a little simple algebra here, figure out n, and then be able to put that into this formula for the sum and figure that out. So I'm going to distribute the 4 here. So I'm getting 432 equals 4 plus 4n minus 4, and those two go to 0. So I simply have to divide 432 by 4. So n equals 108. Now we can put that in up here. So let me get rid of our n and put in 108. And now we're ready to do our calculations. I'm going to pull out a calculator here. So I've got 4 plus 432 times 108. And then we're going to divide that by 2. And what I get is 23,544. So that's our answer here, 23,544. You can tell that this would have been a pain to try to just crank out manually on a calculator by adding as you go up. All right, let's try the one in this other notation, the sigma notation. What we want to do here is actually sort of make it look like the one on top because we need to figure out what D is, what's the difference between each step. So we at least need to calculate a few steps, or a couple anyway. And we need the last term and we need the first term. So let's go ahead and do that. The expression is 2j minus 5, and we're starting with 1. Okay, so 2j minus 5. If I put in 1 for that, 2 times 1 minus 5 equals negative 3. So a sub 1 is negative 3. Let's do a sub 2. So if I put in a 2 here for j, I would get 2 times 2 minus 5. That's a negative 1. And then a sub n, let's put in, so it ends at 122. So let's put in that for j. So 2 times 122 minus 5. And that's 244, so 239. So a sub n equals 239. Now the difference between each step is 2, and you might have seen that right away because our expression is really just a linear expression with a slope of 2, or you're multiplying the variable by 2 every time. So we're going to go up 2 every time. So when we use this equation here, a sub 1 is -3, n we don't know, and then d is 2, and all of that is going to add up to 239. So let's multiply the 2 through here. So 239 equals -3, and then plus 2n minus 2. So this is 239 equals 2n minus 5. We'll add 5, and we get 244 equals 2n. Then we divide by 2, and we get 122 for the number of terms. And maybe that didn't surprise you. Maybe you could see that coming already. But let's use that now to go back to our sum formula. So our sum is going to be 122 times the first plus the last. What was the last? 239? Yeah. All divided by 2. So let me pull out my calculator again, and we'll crunch that out. So I've got a -3 plus 239, and we're multiplying that by 122, and then we're dividing by 2. And what I'm getting there is 14,396. So 14,396. So that is a little bit of work with arithmetic sequences and finding the sum of their terms.